So with that, you remember I did say that like where we ended. We ended at the point when we had a couple of deployments stood up, right? To be exact, if I'll check my cluster right now, you'll figure out that I have a couple of deployments. In fact, one is a service, another one is a client stand up. So basically, to visualize this all up, we'll go from the point of we have Istio Bingo service and we have so-called Fundraiser service, right? Both of those are nice tools to basically or generate the traffic or basically have an endpoint that you can do the test against, right? So what I want to do in the next 20 minutes is spend time on the whiteboard to depict all the components that we have in the picture to basically to enable you to understand what other things that we're going to do here, right? And at the same time, I will cover the homework exercise task that I tasked you to task you before we ended last time, right? So with that, let me begin. So what we know, and I just want to emphasize that what I have here right now, I have nothing else as Istio class Kubernetes cluster, right? This is the Kubernetes cluster that I run. That basically it has couple of namespaces, and in fact, those namespaces do equal to deployments. There is a namespace for IO, and there is namespace called HTTP Bingo, right? Which technically outline our client namespace per se, client service, and here it's more like a provider service, right? That I will would call it like that, right? And there are instances. There is a single instance of Port.io. There's a single instance of HTTP Bingo that runs against, right? So what we do know, right, as we've been covering this last time, we know that we have this. Most of those deployments, they do have the actual sidecars attached to them, right? So basically, those sidecars that you can see here that basically are being attached to both of those deployments, right? And in fact, what we have talked last time, we know that communication between those two, right, they are actually across the sidecars, right? So that means there is a definition of outbound connection, which is basically an inbound connection. And what we also, what I want to clarify here is simple as that. So this is the client service, right? Which will go and directly hit a provider service, which is HTTP Bingo in this case. And in fact, what you see here is just a reference to it, right? So from the terminology standpoint, there are things that I want to call out, called upstream and downstream, that I'll put here. And there's also things that I want to put on the side, such as basic terms, inbound, outbound, right? And also I want to put on the table like client server sort of stuff. Right? So think about that, right? If we talk about sidecars and we talk about Istio, where the load balancing decision done? The load balancing decision is performed at outbound, right? This is where the load balancing decision will be. So basically, when Fordio client wants to hit a Fordio HTTP Bingo service, right? Server, what it will do, it will have awareness of all the servers to make a decision, right? So that's like important to call out, right? The load balancing decision done outbound. The sidecar that connected to Fordio is aware about all the endpoints because in fact, there can be multitude of those be deployed. And in fact, they'll see the multitude of those being deployed, right? Because this is like more, I'm showing to you the things that, the examples, the references, but in fact, there'll be always a collection of endpoints, right? That every sidecar will be aware. So in this case, this is who does populate those endpoints? Who does orchestrate the configuration of those envoys, right? This is, again, the reminder. We do have istiod that runs within the Istio system namespace that is responsible to program the data path, right? Meaning that when the sidecars bootstrap, they will contact and establish the connection to that istiod that is located in the system namespace, and there'll be a continuous feed of the configuration towards those sidecars, right? That implies that if the service will scale up, scale down, more endpoints will add, right? The new services will add. Let's say this is a green version, there will be a per se a blue version, and that's where technically I want to make this more purple, right? There'll be awareness to it, right? There will be awareness, there will be continuous awareness and continuous configuration updates in regards to what? In regards to the sidecar configuration. All that configuration updates will be orchestrated by the istiod that runs in the system namespace, right? So to recap, once again, we know that configuration dynamically being updated. So meaning that there is a discovery service that runs on the sidecar, right? And sidecar populates istiod of what it is aware. In the same time, istiod populates of what it is aware, right? But majority of the stuff is basically also istiod discovers from the Cube APIs too, right? But this is not a task of me talking about how istiod exactly discovers it. What I'm trying to call out here, the sidecar will be programmed by istiod. This is as much as I would like you to basically capture. And then when that is there, when the load balancing decision has to happen, that for the IO, this client will have the collection of endpoints and decision will be done at the outbound level, at the client level, not the inbound. The load balancing decision in the mesh done outbound of the client, not inbound. This is like a very, very important point here. And then from that standpoint, if you think about that, what is downstream, what is upstream, right? In this specific case, your backends are upstreams. Your downstream is actually Ford.io, right? So this is your client, right? This is where those things that you will see in the terminology, and will be a lot from the point of error codes, logs, other elements, like what is upstream, what is downstream, what is the client, what is the service, what is like outbound, inbound, those things that I want to basically set on the stage, right? So with that, if I'll come back here right now, right? What I would like to know is like if I'll go to Ford.io client, which is in this case, this is my Ford.io client, and then let me quickly run those. So I need to repeat those commands. I have them handy here. So I'll just remember to export this and then export that, because you remember I was doing deployment of those two in the past. And you remember I was doing something like that before, right? So that was basically, what I'm doing right now, I'm doing a connection, right? And you can see here, right? If I'll go right now to that specific service, and there will be, per se, what is that? HTTP bingo pod, and I'll just do this. I will not, right? By doing this, I see the container log, right? But remember, like there are two containers. So I have to specify which container I want to see. And in fact, I want to see the Istio proxy container, right? So you remember, right? Like this is a 2-container deployment. So, and if I want to see the sidecar logs, I have to specify the Istio proxy, right? And you can see here, this is where I can finally go and see, right, the log entry. So how that log entry was added? Well, that was the page. I think Artem sent that too. So there's a page, how to enable Envoy Access Logs, right? There's a multitude of those things how to enable it. But I think if you go through it, what you understand that I mean, there are telemetry APIs, but technically that's what you had to do. You had to do istio install, and enable specific mesh config property. By the end of the day, I will show you how production-grade mesh config looks like. So as you already can see, the mesh config, that means, oh, I deploy Istio that implies that I might need to set a collection of the properties to it to basically make it look like more consumable than demo, right? Which entitles that there is a config that exists somewhere, and that config may have multitude of those properties be set, right? But with that, so just to keep it simple and straightforward, you can see here that that's basically what was the task, right? Of course, the log can be customized. There's other bits that they talk here about and why it's important. But with that, I want to show what I want to show you, right? I want to show you that this is what? This is inbound, right? See, this is inbound connection, right? And also, if you'll go see here on the Fundraiser pod, well, I guess, of course, I failed because I better do Fundraiser here. What do you see here? I mean, to be fair, I'll just do this upstream and then basically, yeah, that's bad. Just a cat. And then this is Fundraiser, and this is the same get by, yeah. So basically, what I'm doing right now, right? I'm showing to you, and I'll move this up. I'm showing to you the log entry. Wow, that's being originated where? Well, this is mess up. Hold on. I'm showing the log entry from here, and I'm showing to you log entry from here. This is the proof that communication happens, again, from the sidecar to sidecar, where you can see the outbound connection, right? And you can see the inbound connection. So from that standpoint, what I want to do is first, I want to show you, like, I want to do the elements like that. I want to capture the IPs. So you can see here, the HTTP bingo IP is actually, this is the IP. If I will go and do the Fundraiser client IP, will be 16. Others will be opposite for the reference purposes. But basically, this is the client IP, right? This is the client IP, Fundraiser. This is the server IP, right? Which is this. Again, client, downstream, or server, upstream, right? So with that, if you look here, what we see the outbound transaction, right? From the client towards the server, which is here. So you can see here, as I was saying to you from the start, not yesterday, but on Wednesday, the communication will be, I can't just go and basically the communication will be originated directly from the client to the server. The kube proxy or service IP of Kubernetes will not be used, right? So you can see here, this is where the connection comes in. It comes in there and basically, and being originated from where, right? That's it. So there's something that you want to see, right? Kubernetes service. I mean, I'll just do this and basically grab Fundraiser and then grab it menu. So you can see here, there's a service IP for HTTP bingo. So I'll put it here, Kubernetes service IP. And this one is also, it's not needed, but I'll put it here. For the client, it's not needed, create more confusion. So technically, so you can see here now, you can go and read this line from the saying that here is the server that we will hit, right? Here is the client that's there. Here is, right, an awareness of Kubernetes service IP that we don't use, by the way. And this is what the port, this is the actually the outbound port that's been established. So what you really want to see here, it's the communication is between this, which is destination, and between this, which is the client. That's it. So then if you go back, if you go to inbound now, because this is outbound, and if you go now to inbound, you'll see the same story, right? You'll see this being a inbound connection, which you see that here it says inbound over here, right? Because here it says Doesn't say, so it does say outbound, you see? And here it says inbound. So, and of course, inbound, but that they'll see the outbound. This is the cluster anymore, and I will detail this. But this is again just to give you an idea how to read this a lot. This is important. This is important matter because a lot of the things to understand, like if you want to understand, troubleshoot data paths, enable retries, do traffic management tasks, do security tasks, it's important to basically have an awareness of what the logs are, right? And it's important to understand what is downstream, what is upstream, what's the client, what is the server, right? What else, how to look this all up, how to read this all up, right? So, by the way, any questions here?
Yeah, I think I have a question. I did it yesterday and also with logs, and I have a question. We can like curl to SVC, and
Yes.
it will work. But container connects to container API, yeah?
So it still will lock. It will like the point is we do like it's accounted, right? It will lock, right? But this is more like let's say a different use case to support, right? This is like more one-off use case to support, right?
And how it's work? SVC connect to sidecar or to Fortio in this case?
Well,
When we curl.
it will still connect to sidecar, even though if you curl this IP address, it will still connect to the sidecar.
Okay.
So you can't bypass the sidecar. So
I tried using like pod IP, no cluster IP to pod, and you can see a log with error.
depends what the connection you want to do. So basically, if you check this out, right, what I'm doing here, I'm doing curl, right, and this is so if you do this, right, like that, right, and then if you do like that, it will not work, right? So basically, you can see here. So that's basically if you like doing this like that, what you get there is well, this is the gotcha here because of this HTTP bingo service. I know why it does work like that, but it should not work like that. This is just me playing with different things. But long story short, you see, and so in this case, let me see. This is always, when you're trying something different, it's always good. Yeah, so it's still intercepted. Still points by IP address, right? So that's basically that point is. What I wanted to do, I didn't want, because what I didn't have here in this connection, I didn't have the host header set. So I wanted it to fail, right? But if a sidecar, it won't let it fail, right? Basically, that's it. You can see here. But that's inbound, yeah. So you can see here, this is the connection line I used versus this line.
Yeah, it was like inbound pass through cluster IP vector.
Yeah, if it's passed through,
Like,
there is not much for those. This is really, this is like it's a good point. So per se, right? If I'll go here right now, pick up. So it's important to see those logs on the client, right? So let's do this. And then here, see, there is no pass-throughs. Whenever you see pass-throughs, so per se, I'm doing this on this port here, and I'm going to google.com per se, right? And then what you'll see here, you'll see in point like what do you see here? You see pass-through cluster, right? That's what you see here. So you're probably seeing similar stuff in IP address. So when that happens, that means this is an outbound endpoint, which is not part of the mesh. Pass-through cluster implies that you live in the mesh. Pass-through cluster implies that there's external to the mesh endpoint.
Okay, I think I understand now.
So also something important, right? Like when you do those bits, you need to make sure that if you label the namespace and you didn't restart, the deployment, you'll still have a single deployment there, right?
Yeah, it was like issue, but I find out it in Istio docs about namespace and this auto. I don't remember how it's named. Auto add sidecar.
Yeah, the injection imitated book. Yeah. Alrighty. So so check this out, right? So we're doing those tests, like I draw this picture, right? So, and then it's actually why it's important to have those, right? Why it's important to understand is because eventually you'll start seeing issues there. It's important to enable you to read those logs and understand there's like basically there's inbound logs, there's outbound logs, but there's also a number of elements here that I want you to basically detail further down the line. So what it means, let's take a look, right? So there is a command that you already seen that we have this istio command, right? We use it to install, right? I don't use it like install, like this is not what you use daily. Like with istio what is daily task, and daily is a bad word to say, but technically daily, what do? You use the proxy config stuff, right? There's a proxy config command which enables you to pull and review the configuration that is actually programmed within the Envoy. So think about that. Technically, there's Envoy programmed, but what is inside? How to check this out? How to understand what the sidecar is? How to understand basically what's going on there? And why? Because technically there's something going on. You want to troubleshoot the Envoy, or you want to troubleshoot point-to-point connection between specific services. So you will want eventually to troubleshoot data paths, and data paths implies troubleshooting Envoy, and that implies understanding what Envoy configuration actually is being applied. So this is more like advanced use cases. This is not something you'll find in those classes at all that we talk. But you know, I think I take opportunity. So we have quite small group here, and I'm changing a bit the format for this because I want you to sort of take a look from a different perspective to this, right? And let's open this up. So let's go fuse it down and let's open this up. When we talk about the 4.io, right? There's a client. The sidecar, it's like our load balancer, right? So basically, here's our 4.io deployment, right? Which is Envoy. Oh, what the? So this is our Envoy proxy. So what kind of configuration elements Envoy proxy has? So if you work with load balancers, any Nginx, you know, you call it Lev5s, you know, Citrix, HA proxy, whatever, you know the thing, you know, like the principles that in order to load balance, we need to create what? Listener, right? Which basically will be our external endpoint, like who will be hitting, like listener. Listener, which is technically usually it's IP plus port, may have multiple hosts, which is technically routes. Under that, like under routes, right, you may have different collection of the pull groups or pools or collection of the services, right, or collection of servers to be exact, right? That goes to the point of listener may have routes, but in the same time, listener can be directly bound to the collection of the upstream servers or servers, which are in the group in Envoy terminology called clusters or code cluster. And then from the cluster standpoint, as I mentioned, cluster is a pull group, pull list, pull will have a collection of endpoints such as an actual endpoints, actual pool members, right? Then what else you have when you talk about load balancers? Usually you know that the biggest thing that load balancers, they also host secrets, right? Secrets such as your certificates, right? So technically this is already a dimension of a view that that will be used in majority of the cases when you want to troubleshoot. First of all, well, I want to understand, did my sidecar get a certificate, or there's something going on with my with my connection? How to troubleshoot the secrets, or how to troubleshoot the endpoints. And you see here, I'm saying sidecar here, but in reality, it can be a sidecar or it can be a standalone gateway deployment. Both of them are envoys. Like basically, this will be our gateway, which is outbound Ingress gateway, right? Both of them will have the same, properties. The difference between gateway and the sidecar is usually attached to the deployment. Gateway is like, welcome to your gateway, welcome to your Ingress controller, right? And that's what you'll see here. As soon as I say type Istio cattle, and you can see here what I can see here. I can see, by definition, I can see collect listeners, routes, clusters, endpoints. And then you can see here, this is written by developer. So at the start, and then order is horrible because technically, or you use like alphabetic order or you use logical order. There is no logic into this ordering. In reality, what you see here, you'll see, do you see listeners? Yes. Do you see cluster routes? Yes. Do you see clusters? Yes. Do you see endpoints? Yes. So let me go and decouple this in the perspective of this specific service, HTTP bingo. So is http-bingo.svc.cluster.local is a route? It is a route. What is the listener? The listener is an IP on the port what? On the port 80 or 8080. Actually, it's 8080, right? What is the port? Like this is, see? Yeah, it's 8080. This is the listener. What is our cluster name? Cluster name is more artificial grouping object, right? And you can see here the cluster name because we look where the decision done. This is, you remember I told you, where decision done for the load balancer. Decision done at outbound layer of the sidecar. So decision being done at the 4 layer. So basically, here's the cluster name. It's called outbound. This is just a name. Outbound HTTP bingo cluster. This is the cluster name, right? And then what else in points of the cluster? This is the endpoints of the cluster. Oh, that's, you know what? I think I did mess it up a little. I apologize. And I will show you why I messed it up. This will not be a right listener. This is me being gateway. What? Hold on, I can do it. It's Friday. It's not that late for me. It's not even 2 p.m. Okay. So let's take a look. Let's start looking through it. It's like theory. It's always exciting in a way. So what the Istio cattle config allows me to do, it allows me to do bits like that. I can go and do configuration for each of the block. I can go and dump all the configuration, which I will not do. But what I will do right now on purpose, I will go and specify the deployment name. I'll specify the namespace, and it will give me a table of listeners, right? And that's where it's actually getting interesting, right? So you can see here, this is all the listeners that I have, right? And you see that there is a one listener that I made a mistake. And it was an absolute mistake that I have done, is I did put an IP of the endpoint to the listener. That was my mistake. That was just me not thinking. That was just me talking. Because listener here, it's actual local host. But this is a sidecar. It's locally listens and intercepts all the queries that goes from port AO, right, to outbound port 8080. And then when it intercepts, it will look, is there a known route? Or if there is no known route, then it will be passed through. So let's take a look. Is there a known route? If I'll go do here and do routes, check this out. There is a known route, right? Called HTTP bingo with the cluster associated. Well, this is the route, right? You see here, there's also inbound pass through. Guess what? No routes. You go outbound. I don't track Google's and either the rest of the stuff. So hold on, I don't like the formatting. I better. Can you see it? By the way, is it well? Can you see it well?
Yeah, it's okay.
Okay. Right. Okay, perfect. Good. So that's it. So you can see this is the route. Then from the route, what we want to see, we can go, hey, I want to go and see a collection of what? Clusters. So I'll just be lazy and I'll just put this Istio clusters. And again, I'm looking for, when I do clusters without specifying the route, I'll go and see all the clusters, right? Obviously, what you want to do is like those things do allow you to see, hey, show me, right? The cluster, right? For what? For HTTP bingo, dot svc cluster.local. And here is my cluster, right? So this is where it, like, you see, I'm showing you the cluster. And then eventually, okay, what about endpoints? I can go and start looking to the point of, okay, here is my Istio endpoints. And then basically I can say, again, I need to specify the deployment because I'm looking for specific sidecar. And I can grab simply by HTTP bingo, for example, for this case. And here we go. I'll see for this cluster, there is this endpoint, right? Which is that outbound endpoint. So there are multiple use cases. First of all, if I want to troubleshoot endpoints, I go and troubleshoot endpoints, right? If I want to troubleshoot what is the actual configuration applied, there's elements like -o YAML to actually show and go and investigate a complete cluster configuration. So this is here. If I'll just go there and per se, like go here, right? And then what is that? Yeah, this is our like, sorry for the widescreen, but that's a widescreen day to day. So basically, you can see here, there is a configuration for this pool. You can see the load balancing policy that's being used, right? You can see much more to this, like what's happening. How is MTLS enabled between the services? What is TLS properties? There's a lot. This is, this is where, here's the reality. You will not be looking to this daily. In fact, this is more like advanced mode to do so. This is not day-to-day service match tasks. This is not day-to-day technology tool. This is not day-to-day trivia per se. This is more like, and let you understand, this is, I'm doing this, so I want you to understand that there is a sidecar. Sidecar, Envoy sidecar, it's a fully functional load balancer that has the configuration that entitles it has a listener, configured routes, configured clusters, configured endpoints, right? That where you can go and actually see what's being applied in the actual live data path, right? So, and that it can be done for the sidecar, it can be done for gateway, no difference, right? All this configuration will be orchestrated by Istio. All that configuration will not be applied by you. You will never manage those YAML files that you see here. Well, there are exceptions where you want to go and apply Envoy patches. But in reality, think about that. Istio provides you much more user-friendly interface to interact with all this. So you don't need to know Envoy to operate Envoy. So that's sort of a gotcha here, right? You don't need to know how to program the Envoy. You need to know what Istio can provide you from the use cases so you can enable those features within the Envoy. And that's basically, in reality, Istio is a consumption level for the Envoy. Istio simplifies a consumption of the Envoy functionality. And we will talk about that, right? And then basically that's that part, right, where like we have the sidecar, we have this Envoy configuration. There is so much we can go and take a look inside, but should we? The only reason I went through this because I wanted to build out the theory. I wanted to build out the foundation. I want you to understand what the sidecar is, again, what the client downstream, outbound, inbound, what is an Envoy proxy, how it's being orchestrated, right, and all those elements, right? After, like, as I'll switch to the slides, we'll be more lighter on details, but I'll keep coming back to those fundamentals that I just covered here. Any questions? I know it can be a lot, especially for the Friday, especially for the 8 p.m. Friday. So, that's probably you'll see the rest of the slides today, and the rest of the theory will be more like sort of Mickey Mouse-like presentations, like with those shiny animations around and all that stuff, right? So let's do some of those shiny animations before breaking for the 5 minutes break. So what we have done, we did install Istio, we did deploy the workloads. We understand there's a lot being done by Istio to program the Envoy. You don't need to know Envoy, but Istio does use Envoy. And in fact, that's all the magic happens, but there's a foundational abstraction that happens by Istio towards the Envoy. So what we have here, right? So like we deployed the istiod, we deployed our services, and this is the demo app that we will also deploy, which basically has a collection of the different services, such as product page, ratings, reviews, details. This is a book info app, right? We know that each of those, right, run app and also have a sidecars, right? All of that has been observed, right, and programmed by istiod. All those sidecars observed and programmed by istiod, right? So then that's basically the program stuff. That means then all the outbound decisions and the load balancing, again, happens where? This picture, this outbound, right? All the communications done always sidecar to sidecar. So with that, when we talk about mesh configuration, we talk about configuring the Istio. We're talking about working with Istio customer sources. We don't talk about going to the Envoy APIs. We don't talk about, hey, go to Envoy proxy and figure out what does it filter and Envoy does. No, we don't talk about that. No, we talked about specific desires, specific human-friendly APIs that I established to define basically intentions, right? So they're more or less intention-based APIs, not necessarily like hardcore developer-facing APIs, right? So that means an example here, right? If I want to, right, change or apply, let's say change the load balancing algorithm for the sidecar, what it will be. You remember, I went here, right? I went and I was like, well, there's a cluster. Like you see, I did this like bam, 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 this command and all that stuff. Then I did YAML. And then on the line number, on the line number 100, whatever, no, not 100, whatever, but there was that LB policy, right? And this is the LB policy, right? LB policy list request. So like basically load balancing policy, again, where the decision done on outbound, done at the client level, right? So this is now I want to change this policy. Doesn't mean that I have to go and figure out how can I patch this config. No, that basically goes to the point of understanding that you will have to employ Istio configuration. You will have to use Istio, like provided CRs to make your life much easier and set this configuration. So what implies here? Check this out. If I want to change the load balancing towards this specific service, what I will do, I will create a destination rule that will actually go and set a configuration for my Envoy cluster. Like this is more like this class, more like exception in a way. We usually, when we talk to clients and all that stuff, like, we're trying to keep it simple. And so I'm doing in a way on purpose because I'm sort of this more like a academy like class versus just trying to hide the complexity. I'm showing to you more of the complexity, but in reality, now when you look at this destinational, there is appreciation. So you don't need to know Envoy. Like how complicated it is. It's not complicated. This destinational task that you see here, it's nothing else as I have my Kubernetes CR that says, here is my host, which is ratings. Here is my load balancing that I want to set. How complicated it is. It's not. But what you may miss, and what I will say that maybe a few more times today, is load balancing decision done at the client. It's outbound decision. It's not inbound decision, right? So that means this configuration will be applied over here at this sidecar. Do you need to know about that? No. This is where the mesh Istio handles it for you. What you do, all of them deployed in this namespace, and what it means here, as you apply this configuration, any service within that namespace will be consuming this service using this load balancing algorithm. So, and this is important. This is like a configuration stuff. So think about that. You have this product page talking to ratings, right? And they are in the namespace, let's say book info, right? And then you went here, and then basically, here you go, here's my destination rule that you applied over here. You're applying this configuration in this namespace, right? That implies no matter what the service here, would it be product page, would it be Ford.io, would it be whoever, right? Test service or test client, right? They will all get this configuration applied to them. They will all, when they will call this rating service, will use this load balancing algorithm, right? The question that you should think, what about I have this namespace, like basically my Fordio namespace, which is different namespace, right? And I have my basically lonely client here, right? Which is basically, I'll call them like blue and sketch them and all. Will that configuration be applied here? No, it will not. So in fact, when lonely client over here, even though it's part of the service mesh, and in fact, you know, like reminder, all of them run the sidecar. So I'll just put the orange there. All of them run sidecars, sidecar, everywhere sidecars, right? When this lonely client will be talking to, well, of course, to the rating service here, will this configuration be applying to this client? Well, no, because this destination rule is it's scoped to this namespace. So hold on. What if I want to create a traffic or like cluster-wide policies? How can I go and say any client in any namespace, please apply this policy, right? Meaning that any client, when they will call out my rating service, you have to do this. This is where like there is a so-called relationship. There is a root namespace, which basically called the parent namespace from Istio standpoint, and there is the application namespace. So if you apply this configuration in the root namespace, both of those will get this configuration applied. If you apply it to the specific namespace, you will scope that configuration to the specific namespace. That's it. So this is like more like Istio configuration. So if once again, if you want to have a global-wide configuration, you do your global-wide configuration resources at the Istio system. That implies all that will get applied to the all workloads. But if you do it on the specific namespace, you do it under you do it under namespace. But then something that you should say, hold on, I don't want this policy be applied to every client. I want this policy to be applied to a specific workload, such as product page. Guess what? A majority of those objects, they have a workload selector thing. So what you can say, you can basically expand this destination rule with workload selector that will say, apply this destination rule within this namespace only to product page. So with that, if I'll go right now and say destination rule, right? And what it can do, I can do millions of different things here. What those, you know, this is like, we'll be talking about this, but this is an example here is like what the traffic policy I want to apply and where the traffic policy will get applied, right? By definition, if you don't have workload selector, it applies to all the workloads within that namespace or across the namespaces. Or if you want to scope your configuration to specific workload, you have workload selector for that. So coming back to this, load balancing down and outbound level. If you want to customize this, you have to make sure that this workload, such as client here, will get this destination rule applied. How? Would have workload selector? Would it be under the namespace where the client resides? or would it be under Istio system namespace, which implies that all the deployments will inherit that configuration. So service discovery and load balancing, there is that lab, right? So there is the lab that basically you'll see that majority of the stuff already done, right? I'll just go and prove you the point. There is basically will be your hello world server, there'll be your client, right? There will be basically an example how to curl it, and basically so this is where basically debugging point. So instead of me showing you the debugging point, which I believe like this is a good stuff to show what I wanted to show you, I showed you the clusters, endpoints, and how to read those clusters. So I was, instead of me like basically delaying the lab, I was showing to you all those elements inside, right? So also you can see here, like instead of me doing like a grep under that LB policy, I did output it to YAML and basically show you what is the LB policy is, right? And the end of this, what I have not done yet, I have not done this destination rule configuration. So let's basically go and customize this destination rule. So, for example, this is so I have what I want to have here. I want to do this. I want to say it's my HTTP Bingo service. And I want to make it global to be applied to every client. Because why? My port.io is in the port.io namespace. My server is in HTTP Bingo namespace. By applying this configuration under Istio system namespace, it will be global for the cluster. So, and what will be my host? My host will be HTTP Bingo dot svc cluster.local, and make sure that I put EOF. That's it. So what I'm doing here, I'm applying this configuration. Yeah, that's perfect. So let's take a look, right? How to know it's applied? Well, first of all, like this is where the configuration resides. It's been applied. So basically, if you go and do describe DR, and there are things that by default, Istio doesn't have like a status events, meaning that it doesn't track the status. There is something that's called what is that called? It's Istio status APIs, and well, this is like this is not that. There's Istio status APIs. Yeah, object status APIs. And that's basically, yeah. So hold on, I have it here. Just, some of those bits I have it, but it's internal notes that you keep it for the rest of the team. And I think you keep forgetting where those things are in the actual upstream. Hold on. Ah. Guess meanwhile I'll be on the break. I'll find it. I can't find that thing. Okay. Long story short, by default they're not enabled. It's experimental features. You'll not see the events. You'll not necessarily know if it's applied or not, right? So this is something to call out, right? However, we already know what we know. We can go and take a look, right? The cluster, and let's say if you don't trust istiod, the configuration to be applied, we can always go and validate. But there is something to remember. Why events are not enabled? Because usually the service mesh, it's a big distributed system. If you enable the events, it will cost you more, because it will cost more on the memory of istiod, it will cost more on the tracking and CPU of istiod. That's why the property is not enabled by default and technically not needed, because it's not that common thing that's been commonly used in a way. If you really want to, like if you do hit the issues where the data path is not being programmed, you go and you troubleshoot this, but this is more like an exception where you do notice that regression. That's why you go here to validate this, right? So basically what we have here right now, if I'll grab here, it'll be policy now has changed to random, right? This is, again, this is more educational exercise. Technically, you know, like if that thing doesn't do if this stuff is broken, we have much bigger issue, right? That means istiod misbehaves. But that goes to the point, okay, how to understand if istiod misbehaves, right? Is basically you go and troubleshoot istiod itself, right? Which is that's why I'm going right now here, and I'm showing to you the example, right? That istiod basically that updating the configuration. So there is a continuous configuration update. In fact, if I'll go right now, right, to this 4-day pod and do this, you'll see there is continuous stream towards configuration discovery server, which is istiod. Because think about it, this is Envoy APIs token. It needs to connect to discovery configuration discovery service, and for this deployment, this is istiod. But can you use Envoy with any other control plane aside of istiod? And that's I will talk about that after the break, right? So with that, let's do a break for 5 minutes, right? And after that, I will talk about what other APIs are there and how we can do more, right? And what are the control planes there. So, right. Let me go and see what we have here. So this is those traffic policies. I'll just go. Okay.
I have a question. Why Istio use outbound load balancing?
Think about that. This is sidecar to sidecar, right? How to know the endpoints, right? Like how to load balance, right? It has to be outbound, right? It's like me talking to you. It's like I have to know I have to be talking to you, right? Like you it's like I have to originate the connection, right? But it's like think about it's multiple replicas of you, so I have to figure out that I have to talk to one of you, right? So this is saying it. Otherwise, it's a gateway relationship, right? There has to be gateway in the middle, right? Like what do you have usually with load balancers, right? It's when we use load balancer, it's me talking to load balancer, then talking to you, right? So this is like a classic deployment. Like you go to load balancers, F5s, whatsoever, there'll be men in the middle, which will decide I can talk to you because there are few of you, right? So, but here, that man in the middle doesn't exist. There is no gateways yet, right? There is like I talking to you, right? That means that man in the middle appears to be man in the middle at the stage of me, right? So there are no other way of doing that. I mean, hopefully it
Okay.
helps.
So it will work only in Envoy, but if we do request to not Istio object.
Oh, it's still a lock. That's the beauty. It's still a lock. Like if you do outside of the mesh, you still will be able to originate the traffic, right? It will be not load balance, and it'll be just external endpoint, right? But can you load balance external endpoints? Yes, you can. You can load balance external endpoints, right? It can be sidecar can go and load balance across external endpoints, or it can be sidecar token to gateway, which will externalize the external endpoints. And this is called egress of the mesh when we talk about traffic management or egress management of the traffic. And this is one of the topics I will cover. No, it won't be today. It will be next time, as cliche as it sounds. But today we'll talk about egress traffic, like how we'll get traffic in, right? So, but this is like in the end of the day, when you talk about the mesh, it's how to get traffic into the mesh, how to process traffic inside of the mesh, and how to get traffic out of the mesh for external processing, right? Okay.
Okay, thank you.
So what I see here, it's actually they like this latest article doesn't show the place where those things are. So, and this is, let me show you where like all those samples are, right? So technically there is Istio samples repo. Like literally it's like this is the link, right? So for example, there are a collection of those, and let me send them to Telegram, so you don't need to type it. Oh, yeah. There's so much garbage here. Right here. So that's different samples. This is in fact different, like this is this, and in this specific case, right? What we have here is the reference, like there's a reference in this lab towards this hello world server, right? And this is hello world service, and apparently like what are the titles, right? So in fact, you can always go and do elements like this is basically, hey, here's those two deployments, right? If I want to deploy this service, right, I'll just go and, simply plain and say create an s, I'll just say here hello world, right? And then label an s hello world, Istio injection enabled. And then basically what I'll do here, I'll do apply -n hello world -f, and this. So basically by the end of it, what we have here, this hello world namespace, you'll see that a couple of versions will get deployed, right? So in fact, for you, there is a lot of you'll find a lot of play materials for Istio. There's a lot like those examples, and then when you see those examples, also that's where those examples reside. In fact, if you go to Istio itself, you'll figure out that like when documentation, there's a lot of getting started guides that basically talk about. And you see here, I'm in the sidecar mode, right? Which is technically a de facto mode, which I will talk about ambient mode, which emergent mode, but it's don't take it as ambient mode replacing sidecar mode. Despite that sort of a vision being portrayed as you don't need sidecars, this is like one of those things where it's a mixture of technical and non-technical reasons why that thing exists. So which is a different conversation. That's actually one of those conversations. It's a conversation for a beer, unfortunately remote, but sidecar mode, this is where we talk about it. This again, how to get started, and then how to deploy the sample apps. Also, you'll find like an example of this product page app. What I'm doing right now is, again, I want to show you that I deployed those couple of those hello world services, right? And in fact, what I want to show you right now is like elements like that. So for example, I also do use netshoot container. Like sometimes for those examples for demos, which I don't know, some of you may see, may not, netshoot is simple network troubleshooting container that you can have different networking tools there. Once again, something to highlight, just an educational thing. So I use it to basically instantiate immediate shell for that. So basically, what I will do right now, I will basically go and create immediate shell over here, which basically what you'll see here in this hello world namespace, you'll see me having like this temp shell container where well, it takes time to come up, where basically I've been too impatient about that. Now I have to wait for it to delete and then restart again. So that's it. And basically what I'll do right now, I can do, let's say, cool, hello world. And then you can see, well, it's core blocking or not, how to figure it out, right? Keep in mind, a lot of those things still exist within the service definition. So you can see here, something to call out, right? See, service, kube service, it's your Envoy cluster. So if I'll go here right now and check the endpoints, or like basically check the endpoints for my temp shell under hello world, right? For hello world service, what I'll see here, I'll see 2 endpoints, right? So in this case, you see how they provided 2 endpoints as that. So basically, the port is 5000. See, this is the obvious miss that was done on purpose. right? Basically, that's it. So then there's examples like, oh, like, is there anything else that been missed here? And that's where I want to go here and show you, like, basically this is the whole world. Again, I'm not doing the registration stuff, like proxy stuff. This is done. And then what is the miss here? Simple hello. It's just that's it, right? So basically curl hello, and you can see here this is version 1 of version v2. So you can see here that simply allows me to showcase you there. There is a response that happens between those two versions, right? But in the practice, what we have here, we know there are 2 deployments that are being that exist, and both of those deployments map to the same service. That's it. That's what we have, right? So check this out. This is the first examples of like what you can do, right? We talked about load balancing, right? And we can change the load balancing algorithm. But how about traffic distribution, right? Can we change the traffic distribution for hello world service, right? And this is where first thing that we want to do is we want to establish, right? And we want to establish a definition of what? We want to establish a definition of subsets. What is a subset? Subsets, it's again, this is like Envoy terminology that like the Istio terminology, but technically this is different deployments versions. That's what the subsets are. How do I know there's a version v1 here? How do you know there's a version v2? So technically, if you do see here, if I do kget pod show labels and then basically do hello world, you see there, this is v1, it has the version v1. There is a hello world 2, it has label version v2. So basically, you see here that there is a magic happens. There is technically what we do with this exercise, we do map out. We do create 2 subsets. But how those subsets will be learned, or how we'll learn about those subsets, is basically based on the labels that they have. That's it. This pod has this label, so that belongs to this subset, and the same applies to, you know what? I'll just keep it easy. That's it, basically. So with that, if I'll create this destination rule right now, right, and I will do again this command, points. See, you'll find something interesting. See, there is like a default subset or cluster that exists that has 2 endpoints, right? And there's a subset that now also exists as a subset pool number 1 versus v1 pool, and pool number 2, which is v2 pool, right? So that means if I really go and start looking to the endpoints, right? It's or start looking to the clusters, you'll see that now there are more clusters. See, there's a cluster which is general cluster, and there is a v1 subset and v2 subset, 3 clusters total, right? That includes all the replicas. This is what includes v1 replicas. This includes v2 replicas, right? How we know which ones to map? Because there is a deployment, which is a Kube API object. We know from the Kube API istiod able to understand this pod comes into v1, that pod comes into v2, right? That's it. So with that, what we can achieve from the start, we can do literally a load balancing between the versions. That's it. That's what basically this example now will showcase. So, and this is where I'm like, want to show you this is like, check this out. I now do use a different object, which is called what? Which is called a virtual service. And virtual service there is to modify my listener. So that here, in this picture that I was talking, if you really now correlate all the changes that I've been doing at the destination rule, or mapping, like destination rule was mapping to my cluster. But if I want to modify a route, that will map to my virtual service. So what I want to do right now, if I go to this virtual service or this route, I want to basically have majority of my requests go to V1 and just subset of those requests go to V2. So, and that's what we're getting here right now. Simple as that. Two of the services, subset 1, subset 2, traffic, endpoint. That's it. So that's basically as we apply this over. And then basically go curl, right? What you'll figure out, the majority of those will be under V2 right now. And just fraction of those will be, will be over. Sorry. Basically, fraction of those will be V1. You can see there's V1s are coming. So that actually already sufficient for me to enable canary-based rollouts, right? If per se some of you folks work with Argo or Flagger, or with Argo rollouts, let's say, right? That's it. There's already a thing that enables me transparently promote a service, right? That based on the metrics, I can, for example, rollout or Flagger, you set the metrics and you look for those metrics. Oh no, there is a, yeah. And then basically now, there we go. So that basically goes to the point of, let's say, if I do Flagger, I mean, technically Vivox died. There was a startup behind Flagger. Now it's a control plane, the company behind this. But basically, how to do Canary. And if you go on to this page, Istio Progressive Delivery, what you'll figure out in the day, when you apply Canary, what it will be doing, it will be orchestrating the virtual service rollout based on some metrics per se to classify success or not, right? There's other bits that I will be added here, but technically it will do nothing else as orchestrate the virtual service rollout between those two deployments. It can be Flagger, it can be Argo rollout. So for example, Argo rollouts, and then you go and do look Istio plugin. What was that? There is traffic management. There is Istio plugin over there, and then basically say subset level traffic routing. How to achieve it? Here you go, two subsets behind the scene, and the service mesh is there. It will orchestrate the virtual service. Now goes to the point, it can be rollout, it can be Flagger, it can be your own plugin. Right? So that's like a first real life use case. And this is service to service. This is not gateway. We don't have any gateways yet deployed or whatsoever, right? This is just a basic use case as is. Service to service communication, just basic service promotion or upgrade. So I think that lot, that is completed. That's perfect. Oh, there is that command about like Istio cutoff describe, which those commands I don't find necessary of use, but they're fancy. Like that's it. See, it's like this is more my problem, folks, because as I've been working so long with this, I'm not necessarily helpful with those like fancy commands like this. But this is a fancy command. You can see here, it literally shows V1, V2, distribution. So literally it explains what you have applied in a nice fashion. Doesn't have an OYAML output, I'm wondering. Nah, nothing has OYAML, it's interest for me. So, all right, so let's get going. So deploy up to the mesh. That's the next lab that basically will talk about another lab, which it actually this is just nothing else as this is like we don't like, I already have enough of the lab, like again, I have enough of those deployed. And with that, let's get talking about Ingress, right? So Ingress. How many of you used Ingress within Kubernetes? I assume everyone. Oh, thumbs up. Like Ingress, Kubernetes, yeah. Basic stuff, right? North south, right? So that's where, like technically, what Ingress is, it's nothing else as here is my hello world service. Here's my gateway, right? Here's my client, right? Between client and gateway, which technically This all belongs to the magic Kubernetes cluster, right? Which technically what client will do, it will have the LB type IP address, right? LB type service, which basically can, in a case of actual kill, like hits the LB type Kubernetes service, that basically goes and sets traffic to Ingress controller of your choice, and the Ingress controller of your choice will actually route traffic to like to hello world, right? So meaning that like we can talk about Ingress in Kubernetes, which is the most boring and the concept that it really existed, and it was defined in quite, I would say, it was defined since the project started. I mean, technically, I look into back when it was the first time I was interacting with that. It's like maybe, I don't know, one full. I don't know, 2017. I don't even remember what was the version of Kubernetes back in 2017. But actually, even back then, one of the reasons why I have not been using back then Ingress, because it was not sufficient. So I had to use OpenShift routes, which have been superior towards the Ingress kind. That basically was ridiculous in a way, if you will think about that, right? But basically, it's just a practical name-based, vhost-based routing, right? You define your endpoint, which would be host, and traffic flies from your load balancer, hello.com, to Ingress towards like your service. Can Envoy be your Ingress controller? Yes, you can. By the way, Envoy can understand Ingress APIs. In fact, within istiod, you can have an enable flag saying, you know what, let Istio handle Ingress. In fact, Ingress class can be Istio, and in fact, Istio can manage nothing else as just Ingress, right? So, but let's remind ourselves, Ingress class, Ingress definition is poor. It's poor. It's like, it's very basic. Eventually, what you will see with the time as you use it, you have to use annotations, you have to use use vendor provided CRs and all, because those APIs been very basic. They have been done with that in mind, and they have never been done to target broader set of use cases. It was simple HTTP router use case by definition, right? So that goes from the point that client goes to Ingress, and then based on the host and URI, you hit a specific service. So what you'll figure out, right? Istio can handle the Ingress. This is like one example. So for example, if you already will run Istio, like Ingress class Istio. So what you'll find here, Kubernetes Ingress. Can Istio handle Ingress? It can. Should it? Nah. Migration exercise? Yeah. So then basically industry and Istio is not a new project. It's more than 7 years old now, right? But if you'll see 7 years like back, right, when we had Ingress, right, and there was a clear understanding those APIs will not fit, will not survive, will not last, which was a true statement. Istio APIs have been emerging, and you will see that gateway API, gateway CRD from Istio, virtual service CRD, destination rule CRD, all those, they're quite they really, the amount of options and properties that they expose, not comparable. And in fact, by definition, they've been built to expose all the possible use cases and options within the CR itself, to be vendor agnostic. Technically, Istio is a vendor agnostic, vendor-centric APIs in a way, but they open source. So yeah, it's like that conversation starts. But if you think about that, back 7 years ago, Istio took a step on how to provide a proper traffic management APIs to the community. And I think they've been quite successful with that, right? And that's exactly what we'll see right now, right? And that, just to let you understand, that stuff was really like 7 years ago, like a long time ago, right? So, but with that, right, again, like keep in mind, right, this is a picture reminder. Ingress, or Envoy is just a proxy. It can invoke as Ingress, it can invoke as sidecar to sidecar, meaning that it's still Envoy. So those APIs, right, that been introduced, they've not been solely introduced for the sidecar to sidecar communications. They've been introduced to cover all the use cases, meaning that north-south and east-west. However, how many of you used gateway APIs or heard about gateway APIs? So that's basically, that's the end result of Istio. That gateway APIs, that's basically, let's bring standardized APIs, remove the vendor centricity, which means Istio, and basically use them. And that basically, so Istio APIs been standing behind gateway APIs. And technically gateway APIs, it's an finally open approach to actually how the traffic management APIs should look like and should be like in the industry. In fact, gateway APIs have been finally promoted to V1 version. Oh, not all CRDs, not all CRs, back of November of last year. So folks seem to drop off. Yeah, okay, good. So back in November of last year, I guess that's if you'll go look here, and it's like basically, oh, hold on. Gateway, Gateway API one promotion? It was that, yeah. I told you November, like this is like Gateway V1 finally G8, but yeah, November, October of last year, right? So with that, if you really take a look, they very like what Istio APIs are. In fact, they took the best and what they should take from all the lessons that Istio learned as was maturing, and you can see they end up at the stage where they are. So basically the beauty of those, they provide you an ability to set like roles and responsibilities that you couldn't do with Ingress. And with Istio, there have been questions around those roles and responsibilities. Now, what it implies, there's a gateway class definition, which technically as infrastructure provider, you provide those gateway classes. Then you offload them to the cluster operators to maintain those gateways objects. And then eventually you enable your application developers to stand up the HTTP routes. So with that, how you can do it with Istio? In fact, with Istio, it's a gateway. And with Istio, it's virtual service here, right? But gateway class on Istio, it's a bit different thing. Like that didn't exist, meaning that what will manage the deployment, actual rollout of the gateways, right? So that thing didn't exist, which now exists, right? So, but with that, gateway APIs, again, took the best and evolved what the Istio APIs been and are. And in fact, now, starting version 120 or 120, yeah, I think 121, yeah, it just, they're basically, I keep mixing these things. Long story short, there's a Gamma API initiative, which is, if you look to this, the Gamma API initiative was about bringing gateway APIs to fully supported mode within the Istio. So now, this is like, that started back 2 years ago, but based, I believe 121, yes, 121, that's, well, with 121 release, and this is where we can go and see it, Istio 121 release, the gateway APIs are finally promoted to stable. Like basically gateway APIs are Gamma 122 or 121. I keep mixing those versions, to be honest, folks. Yeah, gateway APIs 122, sorry. Gateway APIs have been promoted to stable for the service mesh. So basically starting version 122, this is the way. This is marked to be a stable way. And in fact, all the examples that you will find people use Istio APIs now fit with gateway APIs. Obviously, there will be exceptions where gateway APIs are built for traffic management. Keep that in mind, right? Gateway APIs don't address all the use cases that Istio does, but for traffic management, that's where gateway API come in to manage, right? And then basically, again, like there's a V1 announcement. Yeah, that's like, yeah, I remember that it just came, that thing, yeah, this article, I didn't read this article yet, to be honest. This is like a brand new stuff that That's what they talk about the changes and so, right? Just, yeah, you can see here, 122 came out like this Tuesday or so, right? But that's again, like I will be showing a lot of those Istio APIs, but can you use gateway APIs? Yes, you can. In fact, you should. So then let's get going. So to recap, Istio supports both of the models. Starting 122 gateway APIs is a stable mode. In fact, like basically have been promoted to stable mode. And basically, the gateway APIs will be used also for the new work within Istio as a method. So before talking about Ingress, right? Something I want to call this out, right? Istio can be your Ingress controller, but like, is Istio only control plane that exists for Envoy? Not really, right? So technically, deployments where I've been exposed and I am exposed where customers think that they run service mesh, but they don't necessarily run service mesh. They run Istio powered Ingress controllers network or Ingress controllers, basically nothing else as north-south traffic management exercise, not necessarily east-west, right? And that's where it goes to the point. Should I use my Istio for the traffic management for north-south? Yes, you can. In fact, you can use gateway APIs and be completely okay. This is very common. In fact, it's very common to admit that as much as folks they think they run service mesh, if you look to it, they sometimes they just run nothing else as Ingress use case within the Istio, which technically not a service mesh use case. So it's just the Ingress management, which is north-south, right? However, I want to talk about this project that basically rapidly evolving, which is Envoy Gateway project, which is also interesting stuff. So if you think about that, Envoy Gateway, right? Envoy Gateway, this is a project that actually serves as a separate project to do nothing else as Ingress management use case. So this is a separate control plane to manage the envoys, and it's solely focused on the point of achieving the north-south use cases, right? How many of you have any of you heard about that?
No.
Yeah, so that's basically it's not that I would say it's not that old, but I think it's now 2 years old now. What? Yeah, more than, yeah, I think 2.5, yeah, 2 years old publicly, yeah. So this is one of our folks that I'm working with, the key maintainers. So basically, the project started from the point us, then VMware back then. What was that? There was one more. I will just go and see who is the. Let's go here and see code of contact. Now it's like committee. What is the committee for release governance? And then what is that code of code owners? Yeah, no, it's just where's the owners? Yeah, so you can see here that's the folks. Some of them from some of them from Tetrate, from VMware, now Broadcom, and then you see Matt Klein also is part of this initiative, who is always behind it, but proxy itself. And basically, there was a page about the current maintainers, but basically, long story short, this is open source project. So that is focused about doing nothing else as promoting gateway APIs, because it's based on the gateway APIs, and promoting Envoy. So basically, it's literally Envoy gateway. So if you want to stand up your standalone Ingress controller and achieve all the power of Envoy with that, so this is Envoy gateway. So basically, from that standpoint, if you'll go and see if what is that, the traffic use cases, for example, exactly the same use cases as we've been doing, you can do with Envoy gateway. So HTTP routing use case, all those things, HTTP routes and all that stuff that we'll be doing right now, I'll be described over here, right? So just
it's correct. Istio Envoy or Istio gateway. It's Envoy gateway, or no?
So Istio uses Envoy, right, as a deployment, right? But Istio is the control plane for that Envoy.
So gateway, it's Envoy gateway.
Yeah, Envoy gateway is a control plane for the Envoy. See, that's the difference. This is a project. This is where it's a bit of mess up if you think about it. But basically, Envoy gateway, it's a different control plane for the envoys. So this is, you see here, like this proxy, this Envoy proxy will be controlled by the Envoy gateway control plane, not Istio control plane.
It's different resource.
It's a different. Technically, it's a different project by itself. Has nothing to do with Istio. So this is like a standalone thing. Like, hey, let's forget about Istio. And if you do north-south traffic management, why need to embark of that Istio? It's just a simple. I need to have open Ingress controller, which technically before that days was in Nginx, but now within Nginx and all this stuff, it still never got to the open stage. So basically, we're that generic open source solution, and that's the intention behind this project, is to drive generic open source solution with intention of evolving this to API gateway. So basically, the open source part is nothing else as your Ingress controller that has a lot of different functionalities. But eventually, the goal of that is to drive this project to be open source API gateway. That will do much more than just like standard Ingress use cases. So, which is different sort of a page by itself. So let's take a look.
I think I have one more question. What the main benefit of using Istio gateway, not Kubernetes?
So think about that, right? What will be that Kubernetes gateway? We talk about Envoy gateway or something else? Or when you say Kubernetes?
No, I'm about Istio gateway API.
Oh yeah, Istio gateway API versus
Kubernetes.
API.
Yeah, Kubernetes gateway.
Oh,
API.
that's it. That's the point. No more anymore. So do use gateway APIs of Kube. So that's
okay.
That's basically where. So that's what people like. This is where like that's why I started. Like gateway APIs do exist because of Istio, and now there's a time to abandon Istio gateway APIs towards the Kube generic gateway APIs, right? So that was always an intention, right? To basically get rid of those and use only gateway APIs as they are.
So it's now only optional.
Yeah, there are two options here, but both of those APIs will exist because there are a bunch of customers still old APIs, right? So for the new deployments, use gateway APIs. For existing deployments, we still have to support the old APIs, right?
Okay.
That's the story. That's a good question. That's actually a good question because that's why I was like, was spending time on that. It's even though it's sort of boring and sounds like commodity, but that's important matter to figure out. That's why this exercise has 3 tasks. One task is to deploy the gateway. I want to deploy the gateway. Then another task, I want to use Istio APIs to configure. And then I want to do exactly the same, but gateway APIs. And then you'll say, well, why I should be using the Istio APIs? I should be using the Kube APIs. And that will be correct statement. So what you'll figure what you figure out as you've been doing the full deployment. The full deployment cuts istiod and also provides you Ingress gateway. So basically, if I'll do this and do kget svc Istio system, what you'll find that I have Istio Ingress gateway, right? So Ingress gateway deployment, in my opinion, if you go to production, what you do, you have separate Helm charts, you version them separately, you basically life cycle that separate. Again, Istio Cattle is the demo tool. It's not the production grade tool. So with that, we already have Ingress. Like we already have Ingress deployment, right? And it's important to understand we have Ingress deployment, but now as we have the deployment, it does nothing. So basically, if I'll go here right now and right and do what? Like klogs-f and then Istio system, then Istio system, and then basically right, it does nothing, right? So that's it. It just like basically You know what? I'll do this. I want to capture the IP. This is a little bit easiest way to capture the IP. So echo gateway API IP. So 35, yeah, 33, right? So then, for example, this is from my own laptop. I can go and do this, and guess what? Nothing really will happen right now. So if I'll do this curl HTTP, see, I could not even connect to it, right? Despite I have a gateway deployed, right? So now that's where I need to create a gateway resource that will create a listener. So this is where, if you remember this picture that I was doing here, I was saying to you that this is Envoy. Envoy by definition will have listener. Listener will have route. Route will have cluster, and cluster will have endpoint. So what we know for sure that like if I want to config cluster, it will be my destination rule, but at the same time, cluster is Kubernetes service that I will discover, right? We know that endpoints will be nothing else as Kubernetes pods that will be discovered, right? What we know about routes? Routes are our virtual services that will stand up. But if I want to stand up a listener, what will be the resource? This resource will be called gateway resource. And this is exactly what happens in this lab. If you want to have a listener, we need to create a gateway resource. And this is where it goes. And if I'll go right now and do Istio PC listener on the Istio Ingress gateway, which technically I don't have Istio Ingress gateway, and it doesn't have labels.
So for Istio, you need Ingress and gateway, yes?
For Istio, you need, when you say for Istio, you need Ingress and gateway.
Okay, but with Kubernetes API, we need only gateway.
Well, this is the Ingress APIs, right? So this is the Istio APIs, right? So this is the Istio APIs. In Kube APIs, it will be a bit different, right? It will be, you also will have gateway, but then you'll have HTTP route here.
Okay.
But we'll get there. So this is basically what I'm trying to do right now. I'm trying to show you that kcat4 is the system, and basically there will be no listener right now. Even though I have this physical deployment, right? That physical deployment doesn't have any listeners yet. See, that's it. No listeners. As soon as I go here, well, not here. I go here. No, I actually go here. Jeez. All right, folks. So, okay. Go here. Dun, dun, dun. No, I'm just lazy. What's this? And then Istio system. So what I have here, I'm doing a gateway deployment, and basically this is, I'm just saying this is a gateway which will be, let's say, hello world gateway, because I can overlay multiple gateways. I can create multiple listeners. So right now, if I'll call it like this, let's say generic gateway, and I'll specify the workload selector because this is where that listener will get created, which is in this case, it's Ingress gateway. This is selector Istio Ingress gateway. What that selector is this. I'll go here, show the labels to you folks. What you'll see that this is the Ingress gateway, and this is the label that it has. Right? It has up, and it also has this label, and this label we'll use. This is the label, and then say, hey, stand up this listener. So I will go do and apply this right now, which is probably my generic gateway. And if I'll go right now and do again listener stuff, you'll see here, now I have a listener, which basically translates that 80 to 80. So if I'll do curl right now, I'll have 404. Why I'm getting 404? Because I don't have any route defined, right? This is where I want to go and define route. So this is like where it goes to the point, I create the gateway, and then I want to have route, public endpoint for the gateway. And this is what goes next. And I go here and say, and this is my route, which basically will be like whatever my web front end, and it will be generic gateway. So if you think about that, any host name, any host goes to the generic gateway, and generic gateway, this I'm mapping this gateway, this listener to this route. Please route to what? To http://bingo.svc_class.log. And on which port? And this is like I want to remind you that if I want to understand what the port it will be, right? It will be bingo svc http bingo. And the service port will be, oh, come on, let me slow down. 80. That's it. So then let's go here and I apply this. I mean, I shouldn't be applying this second time over time, but now if I'll go here, I'll see more because now I can go to this IP address and I can go and see the actual HTTP bin application that we've been playing so far. So I, on purpose, fast forwarded a bunch of stuff. That's because I want to start next week on this. This is the most important concepts because this is majority of the use cases will start with the Ingress management, right? And then like traffic shifting and all, because a lot of the traffic management stuff have to be understood. The rest are deviations and variations. So, and in fact, if you'll not be able to fit all the 4 classes, I will book one more session. That will not be an issue for me. But I would better spend more time on those so you can get, you know, basically a value from this. And that will be a key, right? Because technically what we have achieved right now, we have deployed the Istio gateway. We have created gateway and virtual service, which created, which created a listener and route, where we actually pointed this to HTTP bin to go to be exposed. LB time from Google, because I run this Google NLB, actually front-ended my connection, and that's basically what my connection was. It was from external actor to the Istio gateway to this HTTP bin service, which again, the decision was outbound from the gateway to the client. And then basically, if I'll go here right now and do this, you'll find that, see that my client IP somewhere there, Mozilla. Yeah, see that client. My client that basically will be hitting this. That's it. So with that, folks, I wish you a great weekend. So the homework entitles that you have to do those 3 labs, like Ingress with TLS and gateway APIs. I'll spend time with you on doing those and rehash them. And basically we'll begin from the point of rehashing those concepts. But as soon as you'll grasp those components, as soon as you understand that what gateway, virtual service, and DR is, the rest is Lego blocks. And the key of the Istio is if you're able to address traffic management use cases, you already know, I would say, quarter of what Istio does, which is a lot. And to be fair, that quarter covers for and serves for the 80% of use cases. Another quarter will be security, but it doesn't, like, you'll see that those security use cases will be much more simple. And another 50, which basically there's a lot of functionality that there you'll find that it's a niche functionality that's not necessarily that popular and that's been used, but in much smaller ratio and fashion.
Okay, maybe I have one question that I forgot about it. It's about Istio Cattle. So we can use it for debugging reason.
Yeah. Yeah.
only or
You can use it for debug, and in fact, you can, if you want per se. Just this is a good question. So if I want to do this, I can enable logs. Oh, this is I can go and enable logs for this specific. So let's say this is what help, and then what is that? I would say a level HTTP debug. So what I have done right now, I have enabled debug logs for this Istio gateway. Just real-time debug logs. And then every query that I will do right now, see, it's a debug. Like it's in debug mode right now, right? So, but basically that implies that you can use Istio to review your configuration. It implies that you can use Istio to enable the debugs for your sidecars. So Istio is your day 2 troubleshooting utility.
okay, thank you.
Okay. All right, folks, if you have any questions, again, hit me up over Telegram. I'll watch for the messages. Next Tuesday we'll resume. And once again, if you'll hit traffic management use cases, you're more or less ready to do majority of the Istio use cases, because traffic management, this is where the majority of the Istio use cases reside, side of in the ratio. I would say that there is a lot of use cases Istio covers, right? From the scope perspective, it's maybe 25, but from the overall usage, traffic management is 80% of what people use from the service mesh. And that's like security being used everywhere and almost everywhere, but the functionality to config is very small as a bottom line. It's not that significant as you would as traffic management functionality is. It's significant from the end result, but it's not that configurable as you would want. Right? Then stopping the recording.